Example 3. Suppose a random sample of 25 a random sample of 25 has a mean of 75. Okay, so this is the average coming from a sample. What we want to do is to produce a 90% confidence interval for what the true mean. Remember, the true mean is actually mu. Okay, we have x bar. What we're looking for is mu. Okay, and we know that the population standard deviation is 7. Okay, the population standard deviation is always sigma. Okay, so let's write down some information here. Usually what I like to do is start by drawing a picture. Okay, here's my normal curve. I want to have a 90% confidence interval. Okay, that means the middle section I want to have 90% of my values in between these two endpoints here, this point and this point. Okay, if I've got 90% in the middle, that means I'm left with 10% to share in these two endpoints. Okay, I will share these two endpoints equally. The 10% left over, I will put 5% of it into this upper tail and 5% of it into this lower tail. Okay, I'm using a Z distribution because I know sigma. Remember that anytime you know sigma, you can use the normal distribution. Okay, so what I would like to do is find my corresponding Z values. I know that the middle is always 0. I would like to find this corresponding Z value here and this corresponding Z value here that line up with these endpoints. Okay, so here my cumulative probability, it says here, is 5%. Okay, you should know how to do this in a few different ways. I'll use here the Z table way, of course, first. Oops. Oh boy. Okay, there we go. Okay, so here in the middle, you find your cumulative probability here. That would be 0.05, and this will be, of course, in the row negative 1.6, and in between the points 0.04 and 0.05, so I will use the value 0.045. Okay, so what this is saying is this value here is negative 1.645. Because the Z distribution, the normal distribution, is symmetric, I know that this side is actually the same value, just without the negative sign. Okay, so because these are symmetric, I know that this Z value here is 1.645 in the positive. Okay, so this is Z alpha over 2, that's a positive. This is negative Z alpha over 2. Okay, so I have my two endpoints as far as Z values go. What I would like to do is convert them into X values, okay? So I need to convert these into X values. How I do that, of course, is with my confidence interval formula. I start with my X bar, I add and I subtract this Z alpha over 2 value that I just found. I multiply it by the standard deviation and then divide by root n. Okay, so here remember, of course, that X bar we were told in the question was 75. We were also told that the standard deviation was 7. And lastly, we were told that the number of samples was 25. We have all of the values now that we need to do this question. X bar, of course, 75. Add and subtract our Z alpha over 2 value here that we just calculated to be 1.645. Multiply by the standard deviation here, which is 7, and divide by root n, which here is 25. If you go ahead and first do this formula, first with the negative sign, you'll get the value here, 72.697. And then, of course, if you go ahead and do that same calculation with the positive sign, you will get the value 7 77.303. Of course, this can be done in Minitab quite simply by going up to the stat option, basic statistics, a one sample z because we are using the standard normal table, and putting in our information. The sample size was 25, the sample mean was 75, and the standard deviation was 7. If we make sure that we look at our options and use a confidence level of here, we were not looking for a confidence level of 95%, but a confidence level of 90%. And if you ever want a confidence interval in Minitab, always leave the alternative sign as not equal. Okay, press OK and OK, and you'll see that you can get your 90% confidence interval to be very similar to the values that we calculated here. Okay, let's continue on with this question. Okay, Joe claims that the average test score is 78. We want to know if his claim is supported by the data. Okay, remind ourselves of the interval that we just calculated. Okay, our interval said that we expected mu to be somewhere in between 72, that was our lower limit, 72.697. Okay, if you don't know where that is, just if you don't know where we got that, just go back up to part A. You can see that value there. And the upper limit was 77.303. Okay, so this is our interval. This is where we believe mu to be, and here Joe is claiming that the actual value is 78. Okay, so here's the number line. Way over here we've got 0, and here, somewhere around here, we've got this value that Joe is claiming, sorry, not 0.78, but just 78. Okay, notice here that this value 78 is not inside this interval at all. Okay, so what we say here, 78 does not fall inside our interval. Therefore, our estimate does not support Joe's claim. Okay, if it did support Joe's claim, then we would find that our Joe's claim would be inside of the interval that we calculated. It does not, so we cannot say that Joe's claim is supported. Okay, what about what is the width of the interval? Okay, so again, let's just remind ourselves quickly what the interval was. We were saying that we expected mu to be somewhere in between 72.697 and somewhere in between that and 77.303. We can find the width here just by subtracting, finding the difference of the two. So that's 9. Okay, and you can find here the width to be 4.606. Okay, lastly, can we list 2 ways that we could decrease the error? Which, what I mean by that is 2 ways we can decrease the width of the interval. This interval here has a width of 4.6. Is there any way we can make that smaller? Okay, well, there's 2 ways we can do that. Remember, one way would be to increase the size of the sample. Okay, so we want to make n a lot larger. Okay, this should make sense logically to you. If you want to be more and more accurate of information, then it's best to accumulate the most amount of data possible. You want to have larger samples. Okay, the second way that we can do decrease the width of our interval is by decreasing our confidence. Okay, so that's the other thing. Decrease confidence. Okay, so this might not make sense to you at first, but if you think about it, okay, let me give you a quick example here that's related to the situation. If I want to have an extremely confident interval, I can say that I'm 100% confident that a test score is in between 0 and 100%. Okay, my confidence is extremely high, but yet my interval is also extremely wide. Okay, the opposite can be also true. If I want to get my interval to be smaller, which is what we're asking here, then one way I can do that is by decreasing my confidence.